Alright guys, this is the second lesson on inequalities. Today's lesson is on section 9.2, solving quadratic inequalities. So make sure you have your graphing calculator with you because we will be doing a few graphing. So first question here, consider the graph f of x equals to x squared minus x minus 6. You might be wondering what the heck is f of x, because if you try to do this on your graphing calculator, there's no f of x, instead you have y. So basically this is a y. If you want, you can call that y. Now we have y equals to x squared minus x minus 6. So let's graph this. Y equals to x squared minus x minus 6. And then of course we choose the standard grid number 6 for obvious reason. So basically all we need to do, well, at this level we'll simplify things a little bit. So all you have to do to graph this is to find the x-intercept here, and then find the vertex. Then we have the minimum number of points that we can use to graph this. And if you want to be a bit more accurate, you can go to second graph. That will give you a table of values. Okay, so go back here. By eyeballing this, you can tell that it is 1, 2, and 3, 3 and 0, and this is negative 2 and 0. But let's just quickly do 1. And if it is a test, you definitely want to make sure you get it correct. So in this case, let's do this one. We will figure out this, then you can figure out this one on your own. So left bound, right bound, enter, and as expected, we have 3 and 0. Okay, so 1, 2, 3, 3 and 0 right there. As I said, if you want, you can do the same thing, figure out this, but I'm going to skip this part here. So negative 2 and 0. So negative 1, negative 2 and 0. And then for the vertex in this case, which is definitely a min, second trace, number 3 for minimum. Left bound, and then right bound, enter. So that gives you 0.5 and negative 6.25. So 0.5 and negative 1, 2, 3, 4, 5, 6.25. So somewhere around here, like this. As I said, if you want to make this graph more accurate, get a few more points from the table of values. So we have a graph here. Put the arrowhead, and then this graph is y equals to x squared minus x minus 6. Okay, so this is the vertex, 0.5 and negative 6.25. And then we have the x-intercept here, which is 3 and 0. And then for this one on the left, which is negative 2 and 0. Alright, so now next part, where is f of x greater than 0? So basically it is asking which part of the graph when you have y greater than 0. So if you look at this, so this is y equals to 0. Y equals to 0. Anything above this means y is greater than 0. And anything below this line means y is less than 0. If you want, you can call this positive, you can call this negative, but anyway. So let's do this graphically. So if you look at this, which part of the graph is greater than 0? So if you look at this here, greater than 0 would be anything above. So this part is greater than 0. This part is greater than 0. Alright? We know this part is greater than 0 for y. Same thing here. How do we indicate that? We know they are greater than 0 as I just said. So how can we indicate that or write that in terms of x? So you can say that when x is greater than 3, y would be greater than 0. So y is greater than 0 when x is greater than 3. Have a look. Anything for x greater than 3, y would be greater than 0. On the other side, anything less than negative 2, y would also be greater than 0. So x is less than negative 2. Alright? Next, if you look at this, where is f of x less than 0? So that means which part of the graph when y is less than 0. So that means anything below this line, y equals to 0. So anything down here. So let me pick this part here. So for the green highlighted green section, it is less than 0 for y. So in this case, we know this region is less for y. In terms of y, this region is less than 0. So how can we write that in terms of x? So x is when x is less than 3 and greater than negative 2. So that means when x is somewhere between 3 and negative 2. So x is somewhere between 3 and 2. 3 and 2, somewhere here. For these x values, y would be less than 0. Alright, next part. What if the question was solve x squared minus x minus 6 equals to less than 0? So if you look at this is kind of like what we had before. Y equals to x squared minus x minus 6. X squared minus x minus 6. So if this doesn't make sense to you, maybe you can incorporate this. So basically, this question is asking which part or parts of the graph when y is less than 0. So if you think about what I just said, isn't this what we did here when y is less than 0? Except what is y? Y is x squared minus x minus 6. So if you look at that, we actually did this already. Which part or parts of the graph when y is less than 0? Y is equal to this. This is less than 0. So that means y is less than 0. Right? So when is y less than 0? This part. So somewhere between these two values, when x is less than 3 and greater than negative 2. So somewhere between 3 and negative 2, the y value for this graph would be less than 0. So same answer. When x is less than 3 and greater than negative 2. I hope you are so far so good, because at this point we are just solving things graphically, but later on in today's lesson we are going to solve things, do things algebraically. So anyway, now here is another system. So we have two graphs, x squared minus 6 and x. You can call this y equals to that, plot that, y equals to that, plot that. All right? So now plot this, plot this. If you want, you can put down y here, and then we can graph that. So first graph is x squared minus 6, x squared minus 6. Graph this. All right, so let's do the same thing. Find the coordinates of these two x-intercepts and then the vertex. Then we have the minimum number of points that we can use to graph. And again, you can do second graph to look at the table of values. So second trace. This time, let's do the vertex, which is a minimum. Number 3. Enter left bound, and then right bound. Enter and enter again. So this is literally 0, because if you look at this, negative 2.9 times 10 to the negative 6, which is negative 0.000292, something like that. So this is literally 0. 0, negative 6. So 0, negative 1, 2, 3, 4, 5, 6. That's the vertex. 0 and negative 6. All right, next we can find the x-intercept, second trace. Number 2, doesn't matter, I'll just do one of them. You can do the other one to brush up your memory. So left bound, and then right bound, enter. So this gives you, well, not a perfect decimal, but so 2.4-ish, 2.44 something, 2.45, and then 0. So 2.1, 2.2, 2.45-ish. Okay, so 2.449 something, and then 0. I'm going to skip this step here. So if you do the same thing, you'll find that the coordinate of this x-intercept is negative 2.449 and 0. Negative 1, negative 2, negative 2.449, something like somewhere around here. Negative 2.449 and 0. Sorry, the stylus pen is not cooperating. So negative 2.449 and then comma a 0. Okay, and then you can of course graph this. So this one is, if you want, call that y equals to x squared minus 6. Here, I'll just show you another way. I simply call that f of x. Alright, let's do the second graph here, g of x, or you can call that y equals to x. So let's do the second graph. Second graph here, don't erase the first one, just x here, and then graph. So again, you can look at the table of values. So, and definitely look for the intersection point. Obviously, that's one point here for this graph, 0, 0. So 0, 0. Next, I'll just show you one point, how to find this, the coordinate of this point. Then you can do the same thing and find it here. So this time we are looking for the intersection point. Second trace, we are looking for the intersection point, so number 5. So first curve, the flashing cursor is on the blue graph. Yep. And then we are looking for the coordinate of this point, so you might want to move the flashing cursor closer to the point, intersection point we are looking at. So enter, enter again. So this one has a coordinate of 3 and 3. So 1, 2, 3, 1, 2, 3. So right there, 3 and 3. You can do the same thing, and you will find that this point is -2 and -2. Okay, -1, -2, -1, -2. So right there. Sorry, it's a bit messy. -2, -2, and then join that. So this one, you can write down y equals to x if you want. Here again, I'm going to use a different notation this time, or do things in a slightly different manner. So I call that g of x. So g of x. Okay. Next, where is f of x less than g of x? Or you can look at it this way: where is g of x greater than f of x? So before that, let me just bring these down here so that I know which one is which. So for which part of the graph? G of x, which is this. I'm keeping the color coding, and then g of x is the green one, which is x, and then f of x is the blue one, which is x squared minus 6. X squared minus 6. So now if you look at what the question is saying, for which part or parts of the graph when the blue one is less than the green one? You may want to pause for a few seconds and then try to figure that out. Okay, so you can see that for this section here, the green, so the blue one is less than the green one. So if you let me just help you with a highlighter. So again, look at this. Blue is less than green. So basically here, so if you look at this part of the blue graph is below the green graph. This blue is below green. That's what we have here. Now, how do we indicate this, that with respect to x values? So if you look at this is the section of the graph, of the blue graph, that is below the green one. So it is somewhere between -2 and 3. So from here to here, the blue one is below the green one. Okay, but instead of saying somewhere between 3 and -2, in math we are a bit more explicit. We say that when it is less than 3 and greater than -2. Okay, so when x is less than 3 but greater than -2, I don't mind keep telling you guys that, oh, when x is somewhere between this and that, but then you better be more explicit in math here. So, okay. All right. Next part. What do you notice about the solutions from the last two questions? So here is the solution. X is less than 3 and greater than -2, or somewhere between 3 and -2. Check this out. Less than 3 and greater than -2, somewhere between 3 and -2. They are the same. Why is that the case? You might want to pause a few seconds to look at the previous question and then question on this page. What is going on here? So if you go to a previous page, we have y equals to x squared minus x minus 6. So previous page, we have x squared minus x minus 6. Not just that, but this part, less than 0. Less than 0. Now this page, or from above, what do we have? We have x squared minus 6 less than x. X squared minus 6 less than x. These two look different, but how come we have the same answer? Because, check this out. If you move this x from the right hand side to the left, so how? Minus x, minus x, minus x, cancel out. What do we end up with? Left hand side we have x squared minus x minus 6 less than, we still keep the same inequality sign. Right hand side has nothing, 0. Look at this. Aren't these the same thing? Except that instead of doing one equation, we split that up into two equations, or two inequalities. Okay, so some generalization or something you should walk away with from the previous two examples. So the intervals where a function is positive or negative are always bounded by the zeros. So how can you find the zeros, or where are the zeros? They are the x-intercepts. So if you look at previous two graphs, you would always see that there is always something happening around the x-intercepts. Have a look at these two. X-intercept, x-intercept. So this part here is below. Sorry, I'm in the blue curve. So if you look at this x-intercept, look at this. Just look at the blue curve. So right after this x-intercept, the y value goes from negative to positive. Same thing here. Like to the left of this, the y value goes from negative to positive. If you look at the first graph, x-intercepts, let's start from left to right. Y is positive. Then after crossing the x-intercept, it becomes negative. And then when the graph crosses the x-intercept again, this time it becomes positive. So that means something happens after a graph crosses the x-intercept. It may go from positive to negative, or going from negative to positive, or negative to positive, or positive to negative. Okay, so keep in mind, there's always something happening around the x-intercept. Next, this means we can start to solve a quadratic inequality just like a quadratic equation. So that means you are looking for the x-intercepts, i.e. the roots, the solutions, the zeros. Okay, next point. By putting the inequality in standard form to solve for the zeros. So that means if we write y equals to ax squared plus bx plus c, we can solve that. So standard form would be y equals to ax squared plus bx plus c, and then you can do this, something like this. zero product rule, set this equal to 0, solve for x, set this equal to 0, solve for x. Okay, next. So, but it gets different from here. To solve an inequality, we will use, so this time we are going to, for the rest of this lesson, we are going to do the same thing. We are going to talk about which part of the graph is greater than 0 or less than 0 with respect to y. But this time, we are going to do it algebraically. We are not going to look at the graph like what we did. We were just doing examples like that to help you guys visualize this. So we are going to do this algebraically. Okay, how? Here we go. So basically, when we say solve an inequality algebraically, I mean using the interval chart. So how to set up an interval chart? Of course, I'll show that to you in a second. But let's quickly talk about the notes here. So you might want to pause for a few seconds, quickly read through this, jot down the notes. So the critical numbers, there are several components in an interval chart. First thing is the critical numbers. Okay, so the numbers that make the function equal to 0 or undefined. So what would make a function equal to 0? We are talking about the x-intercept. Or what would make it undefined when we talk about NPV, non-permissible values. But here, at this level, we'll just focus on this. So we will find some numbers that will make the function equal to 0. If that's too confusing, basically what we are going to just find the x-intercept, the value of the x-intercept. And then next, these numbers will go on a number line that will make the interval for our interval chart. So I know you're so confused at this point, but just keep this in mind. We are looking for the x-intercept values. Okay, so once we work out even just one example, everything would make more sense. Okay, second part, which is basically what we are coming after, interval chart. We are going to set up a chart because we are going to analyze any questions algebraically. You can cheat a little bit by using your graphing calculator. Okay, so interval chart, but when we say solve or do it algebraically, then we're talking about interval chart. So a chart that shows if the function is positive or negative in a specific interval. So when I say positive or negative, that is with respect to y. Like the first two examples we did in today's lesson. Okay, contains all the intervals from the number line and all the factors of the quadratic. So you'll see in a second, we will put the factors as the heading of each column, and then we will put the numbers in the rows as the heading, like heading of each row. Let's quickly finish this part here. Then we'll work on an example. And we'll be doing some test points. So as I said, bear with me. I know you're so confused. So test points, as the name says, we pick any point to plug that in for testing. All right.